Hi, I am Revathi. I am working as Assistant Professor in SNS College of Engineering. Today we will discuss the topic about stop wait protocol. A protocol refers to a defined set of guidelines and regulations that control the communication between different devices in a network. These guidelines specify the way in which data is formatted, timed, sequenced, and checked for errors during transmission. Protocol is divided into two, that is noiseless channel and noisy channel. Noiseless channel is divided into two, that is simplest protocol, stop and wait protocol. Noisy channel is divided into three, that is stop and wait ARQ, go back and ARQ, selective repeat ARQ. Stop and wait protocol. Stop and wait protocol is a data link layer protocol for transmission of frames over noiseless channels. It provides unidirectional data transmission with flow control facilities but without error control facilities. The idea of stop and wait protocol is straightforward. After transmitting one frame, the sender waits for an acknowledgement before transmitting the next frame. In this case, stop and wait means that the sender provides the recipient's desired data. The sender pauses after transferring the data and wait for the receiver to acknowledge his transmission. The stop and wait protocol, which is a flow control protocol, uses the data link layer's flow control functionality. It is a data link layer protocol that is used to send data through channels with no background noise. It offers unidirectional data transfer, which means that only one of the two operations, data sending or receiving, can concern concurrently. Although it offers a flow control system, there is no error control mechanism. The concept behind using this frame is that after sending one frame, the sender will wait for an acknowledgement before sending another frame. Primitives of stop and wait protocol. Sender side. Rule 1. The sender sends one data packet at a time. Rule 2. The sender only sends the subsequent packet after getting the preceding packet's acknowledgement. Therefore, the concept behind the stop and wait protocol on the sender's end is relatively straightforward. Send one packet at a time and refrain from sending any additional packets until you have received an acknowledgement. Receiver side. Receive the data packet, then consume it. Rule 2. The receiver provides the sender with an acknowledgement after consuming the data packet. As a result, the stop and wait protocol's basic tenet on the receiver's end is similarly extremely straightforward. Ingest the packet and after it has been consumed, send the acknowledgement. This is a mechanism for flow control. Working of stop and wait protocol. The stop and wait protocol's operation is depicted in this above figure. The sender sends the packet referred to as a data packet. If there is a sender and receiver, after receiving a data packet, the receiver sends an acknowledgement for the first packet. The sender won't send the second packet. The sender sends the subsequent packet after receiving the acknowledgement. This procedure keeps going until all of the packets have been sent. The stop and wait protocol's main benefit is simplicity, but there are some drawbacks as well. For instance, if 1,000 data packets need to be delivered, they cannot all to be sent at once since this protocol only sends one packet at a time. Disadvantages of stop and wait protocol. Problem arise because of lost data. Let's say the sender sends the data, but it gets lost in transit. The receiver is patiently awaiting the data packet. The receiver does not send an acknowledgement because it does not receive the data. The sender won't send the subsequent packet because it has not received any acknowledgement. The lost data is the root cause of the issue. In this instance, there are two problems arise. The sender waits an endless length of time for a response. The receiver waits indefinitely for the data. Problems arise as a result of the lost acknowledgement. Let's say the data was sent by the sender and was also received by the recipient. The receiver transmits the acknowledgement after receiving the packet. In this instance, there is no chance for the sender to get the acknowledgement because the acknowledgement is lost in a network. Additionally, there is no chance for a sender to send the subsequent packet because according to the stop and wait protocol, this cannot happen until previous packet's acknowledgement has been received. One issue arises in this situation. The sender waits an endless time for an acknowledgement. Problem resulting from delayed data or acknowledgement. Let's say that data was sent by the sender and was also received by the recipient. The acknowledgement is then sent by the recipient, but it is not received until the timeout period has been passed on the sender's end. Due to the acknowledgement being received after this, it can be mistaken for acknowledging the recipient of another data packet. Thank you.